Hello, thanks for joining our Scripting and Programming Foundations exam prep session. I'm Dr. Blood and happy to have you here. We are going to be using our Kahoot online gaming platform for this, and let's go ahead and get started. Question number one is coming up. We've got 30 questions to go through, covering the entire course, a little bit from every part of the course. We've got some slides to supplement the learning as we go along. Question number one says, true or false? We want to know if computers are smart. So what's your thoughts on this? Got plenty of time to think about this and answer. If everybody answers beforehand, it lets us move the game a little more quickly. And it turns out computers are not smart because the computers are only able to do exactly what we tell them to do. They are not able to do anything more or anything less. They can't make conclusions. So you know what that means? That means computers are not smart, but the programmers are smart. The programmers who are telling the computers exactly what to do to accomplish what it is we want to have done. All right, got a leaderboard. Get points for getting the question correct. The answer correct rather, and more points for getting ahead of other people. Computer programs consist of the following three types of instructions. You need to select three and then click the, I don't know, apply, okay, whatever the button is on your screen. Actually submit it, probably says submit. So three types of instructions. All of our computers need. Without it, we are certainly going to be missing out. So I've been confirmed. It is the submit button that you need to press. Always kind of start with the one in the middle, which is the process. The process is the one that most of us think about. It's where everything happens. It's the actual operation. It's where the program is going to perform all the actions that we want it to do. However, the computer can't perform those actions without a proper input. So we need to make sure we're formatting our input. We're specifying exactly what kind of instructions we're sending in to the computer so that it can then run the process, the middle portion. And then from that, what good is it going to be if we don't have some sort of an output? What's the output? Maybe it's just printing something to your screen. Maybe it's saving a value. Maybe it's sending an email. We don't know. Lots of different possibilities, but we need our input, our process, and our output. All right, moving along. Happy's in first place. That makes me happy too. This question is asking us to select all variable names. Now, this is based on our course. It comes from the Coral programming language, and there are a number of rules that we are given to how we can name our variables. Just a point of note for you, this is the same rules that we're going to use to name our arrays and our functions. The same rules apply. Take a look at our slide to show you what those rules are. It says, in program, a variable, of course, is a named item to hold a value. Here's the naming rules that it does start with a letter. Cannot start with anything other than a letter, A to Z. Then any letters, digits, or underscores. That means you can start with a letter and then have a number, a digit, so a number, or an underscore. You can also have a dash. Names are case sensitive. Don't forget about that. If you have the variable named my name, keep in mind, my name all lowercase, my name with camel case, and my name all caps. Those are three different variable names. And then lastly, as you're declaring your variables, your functions, your arrays, be descriptive with it. Try to have something useful for it so that we can actually know what that variable is going to represent. That makes it a little bit more useful to troubleshoot our programs. So based on that, we have the myvar is camel case. That's a valid one. We have Legos L3G0S, no problem. Bricks and Beams has an underscore, no problem. Why isn't 5 blocks? Well, because you cannot start with a number. What about my num? That has a $sign in it. That's not allowed. And Bricks and Beams, that has the space in it. You definitely can't have a space in it. So be aware of those rules. All right, new leaders there. Another true or false. True or false make things a little easier for you. 50-50 chance, right? Pseudocode will show everything in the program's code. You take your objective assessment. No doubt you're going to have some questions with pseudocode where you're expected to tell what the output's going to be. Describe what's happening. And it's important to know that pseudocode will not show everything. Well, it may not show everything. Generally, it's not. There are parts of the program that aren't really applicable. Maybe spots where you're declaring a variable. You're initially setting it up, initializing those variables. Maybe that's not going to be shown in there. It's not germane for the question. Don't get thrown off on that. Don't go, oh, this program's not even going to execute. It should have an option that says failure. That's not what you're being tested on. Look at the code, translate the code. Sometimes you'll see pseudocode presented to you in a flowchart format. Sometimes you're going to see it in words. Sometimes you will see it in a code base. Doesn't matter. That's all considered pseudocode. Just take it for what it is. It's designed to make things simpler for you. We're going to talk about math. We do lots of math when we're writing programs. So you've been asked to choose all valid mathematical operands. There are 3 of these listed. Did not include addition and subtraction. For addition, you would certainly expect to see the plus sign. For the subtraction, you're going to see the minus sign. But we're not looking for those right now. We are looking for 3 others. This is very common across programming languages. The first one we're going to have is the slash. That's what this is called. This is just called a regular slash over here in your aqua color. It's not a backslash, just a plain slash. That's your division. We had 12/4. The answer to that would be 3. Our asterisk, that's multiplication. We had 12*4. That's going to be 48. The one that's more confusing, that we're not as familiar with at all, is the percent, which is actually not anything to do with percentage. It's the modulo operator, and that's designed to give us the remainder. When we're doing division, we want to know what the remainder is. If I had 12 modulo 5, that's saying what is the remainder if we did 12 divided by 5. So 12 divided by 5 is 2. That brings you up to 10 with a remainder of 2. So that's what we're using that for. So we're going to use the modulo. That's a good question for the exam, making sure that you understand modulo. Next, we're going to ask you about assignments. There's really 2 types of operations. There's assignments, comparatives. And this one is saying that the statement A equals B is an assignment operation. It is true. When we have a single equal sign, that is actually assignment. We'd probably be more familiar with seeing it as a number. A equals 3. The one on the left is becoming the one on the right. We couldn't say 3 equals A. That's just not going to make any sense. You can't do that. You can't say 3 is going to have a new value. So it's what value you're working with, what do you want it to become? So A equals B. A becomes B. If we see it with a pair of equal signs, that's a comparative operation. That means it's a question that's saying, does A equals B? And then if so, you can make your decisions on the criteria that follow. So 2 of them are going to be a comparative operation. Number 7, if you've watched any of my videos, been in any of my sessions before, you know I like to work with Legos. Adults work with Legos. Children play with Legos. But sometimes we've given strict rules by the spouse in this house. It says we can only work with Legos on even numbered days of the month. Which operand can be used for this requirement? To find out if our day of the month is an equal or unequal day. Today is the 22nd. So how can I find that out? I can use the modulo and say if current day of the month modulo 2 equals 0, then build Legos. That's the key on that. So even number, today is 22, and we say 22 divided by 2. If that modulo is 0, that means there's no remainder. That's where you're using it. That becomes very helpful to determine if you're working with a number that's even or odd, or if you just want to find out if you've got a strictly divisible number. Maybe you're counting by 5s, you're counting by 10s. That's what you're looking for. Use the modulo. Way to go, you can't see me. Here, we're going to look at variable types. I've asked which of the following two should not be declared a number. Now, remember, numbers are things that you're working with mathematically. We have variable types of integer, float, maybe you've seen doubles. Those are numbers, but they're specifically so that you can use a value as a number. Why would we ever want to use a number? Well, for math. We also have another variable type called a string. You have things like booleans and chars, and but those are the big ones. Strings, floats, integer. And when we look at this, we can see a couple of examples. 1.25, that's my crane in height. I've got the crane behind me, and we need to know how tall that is. We can use that for comparative. Is this greater than or less than? The total Lego Technic kits, again, we can have greater than or less than. We can find out how many would we have if we needed to sell half of them. But when we look over at these other two, this 04451, that's a zip code. There would be no reason to do math on a zip code. We can't say, oh, I want to send a letter by the U.S. Postal Service to half of this zip code. It is what it is. It's a fixed value. Computers, they can't keep the 0 in front either. So if you take a zip code and you suddenly shorten it to four digits, post office doesn't know what to do with it. It's going to get sent back. So this is a situation where this needs to just be treated like a string. Phone number, the same thing. Well, also, we have dashes in here. You can't have symbols in a number. So that's a dead giveaway. But also, we would not treat a phone number as a number. It doesn't, there's no mathematical properties to that. I hope that kind of helps you understand the difference between integers and a string. Let's talk about maybe some of these different variable types. You need to track the number of pieces inside a new Lego kit. Which of the following would work best? How do you do this? You're going to count. You're going to count your Lego pieces. So how are you going to keep track? How are you going to save that afterwards? Well, if you know how to declare it to begin with. So you declare it by using integer or float. That's what it really comes down to, integer or float. Well, why is it integer? Because a Lego piece is a piece or it's not. If it's a small piece, well, then that's two smaller pieces, but you can't have a half a piece. That's why you're not going to have a float. You're only going to have integer pieces for that. I have another question that I ask where you just kind of get a grasp of what you're looking at. If I said, we've got 20-inch pizzas coming for lunch, 20-inch, that's a big, big pizza. You know, that's like this. And I said, how many how many pieces, I'm sorry, how many pizzas are you going to eat for lunch? Is this an integer or a float? Well, I would say for all of us, hopefully, unless you're Joey Chestnut, you're going to eat a portion of that pizza. You're going to eat 0.1 pieces, 0.2 portions of that pizza. You're not going to eat one 20-inch pizza or two 20-inch or three 20-inch. So there you're keeping track, you're understanding. You're working with a large item. You need to be able to cut it down. If we said, how tall are you in meters? We're not using meters in the US, but it's like 3 feet. You can't just leave that as an integer. We're not 3 feet, 6 feet, 9 feet tall. We need to be able to say 1.8, 1.9, 2.1. There we need to have more precision. Let's do some evaluation. These are good questions here. I can see something like this being on your objective assessment. I'm trying to make all of these similar to what I believe you would see. It says, let x equal 7 and y equal 9. How does the following evaluate? So x greater than 0 and y less than 10. This is where you have to start thinking. When you take your objective assessment, you're allowed to have a whiteboard. So you can bring your whiteboard and you can take notes. Maybe you don't have a whiteboard. Well, in that case, I would encourage you to leave your shoes off so that you have access to all of your fingers and toes, and you can keep track of things that you're counting, especially as you get to loops. All right, let's look at this. It says, how does the following evaluate? X is greater than 0. Well, x is 7. So is 7 greater than 0? Let's use the thumb test. X is greater than 0. Yes, we have one thumb up. And y is greater than 10. I'm sorry, y is less than 10. 9 is y. Boom. Yes, two thumbs up. When we have the word and, that's what we have to keep track of. We have to keep track of all thumbs up. We have two thumbs up. This evaluates to true. Do another one for this. In this one, we're mixing it up a little bit. Now we have x is equal to 7 and y is equal to 9. How does the following evaluate? X is greater than 10 or y is less than 10. We've got some good comments going on in the chat bar there. No difference for this question for the thumbs. We still need to have our thumbs. Uh, we've got x is 7. Is 7 greater than 10? No, we got a thumb down. We got a thumb down. Or y, which is 9, is less than 10. We've got a thumb up. Well, the question there is or. That is our operand that we're looking at. When we have the or, we just need to have one of our thumbs up. So this is true. This is true. Both thumbs up. That's true. The only one that's going to be false is if both thumbs are down. Don't be afraid to use your thumbs. Let's see what questions. That's question 11. So we can go over here and just take a quick look. These are our logical operators, and this is referencing our and, ors, or not. We looked at and. That's when both are true. We have our or. That says at least one of the two operands is true. And then we have not. And that's true when the one operand is false or vice versa. That is definitely the trickiest one. And honestly, I doubt you'd see anything about that on the exam, but we'll at least mention it for you. All right, let's see. How'd we do on that question? Majority, if you got that right. Good work. Let's head into loops. If I was writing this exam, I would have lots of loop questions for you. We've got a few different slides for when we finish these up. It says this type of loop will always execute at least once. One of these is more wrong than the others. Let's see if you know which one is more wrong. The blue one is more wrong. Why? Because if then is not a loop. Okay, that's a red herring really. It's just to throw you off. If then expressions are conditional. When a program hits that, it's going to evaluate that one time and move on. That does not in itself repeat. There is no loop for it. Now, you will frequently find if then statements inside of a loop where the loop is causing it to repeat, but there's no such thing as an if then loop. It is one and done. Well, again, it's not even one and done. It's just the line itself. It is just a single line. So what are we looking at? One, it's going to execute at least once a do. I think of the old Nike saying, just do it. Because a do loop will always execute at least once. It's going to get to it. It's just going to flow right through it. It's not even going to look to see what is being requested until it gets to the end. And that's where it's going to evaluate the condition to see if it repeats. Alabama, moving on up there. Next question says to use this kind of loop when you know how many times it should run. Examples why you know how many times it's going to run because you've told beforehand. I want you to enter 4 numbers so that we can come up with the area of some kind of polygon, or maybe you've got an array with 10 elements, so you know there are 10 elements to work with. When you have such a condition, you typically want to use a for loop. You know how many times it should run, you're going to use a for loop. 14, what is put to the output by the following pseudocode? So this is coming out of the loop section, but you could also expect to see something like this in the algorithm section. The algorithms are certainly going to have things where they expect you to be able to follow the flow of the program and determine the output, determine the ending value. So you have lots of time for this question. I believe a full 60 seconds to look this over. Here we've got pseudocode, really everything to execute. The full program would be included right here. So it's not always going to have the pseudocode this clear. So I wanted to give you a good example for this. When you take your objective assessment, it is important to be extremely precise on this. Let's take a look. I'm going to go back and show what we're looking at. It starts off, our program says that we have a value of x that's 3. Okay, so we didn't actually initialize x, so that, see, we didn't have the full program. And it tells us to put the word brick number space. That's the precision part. Be sure you're watching for any spaces or anything. Brick number space to output. We have a do statement, which means we are absolutely going to execute this loop. We're not going to even worry about what the conditions are. It's a do loop. We're going to execute it. What does it tell us to do? It says put the value of x to output. That's 3 and a space. So now we have brick number space 3 space. We're going to subtract 1 from x. That's a 2 now. And here's our condition. If 2 is greater than 0, then we're going to continue. So now we're putting a 2 space. We're subtracting 1. 1 is greater than 0. That means we're going to put a 1 space. We're going to subtract 1. That leaves us 0. Is 0 greater than 0? No, it's not. So that's where we stop. Brick number 3, 2, 1. How do we do on this? Most of you got that right. Some people did put the 0. Some people didn't see the brick number part. And some people started at 210. So lots of different variations of that. I got you all on that. Be very careful with these. These can be tricky. You want to spend a little extra time looking at exactly what the code is. Make sure that you are paying attention to these signs. While x is greater than 0, 0 is not greater than 0. It could have said while x is greater than 1. Oh, be careful on that. Make sure you're paying attention. Is it 0? Is it 1? Is it greater than, or is it maybe greater than or equal to? Any of those things could be changed. You definitely want to pay close attention to them. Oh, they're doing a great job, by the way. Let's mix this one up a little bit. What's the output of this program when the count equals 4? I'm not giving you as long on this. You had a little bit of time to practice from the first one. Doing a nice little difference here on this. Lots of people are putting their answers in the box. Got just a few seconds left. Oh, everybody finished up early. Brick number 4. Why? This is what we call an infinite loop. when we use a while loop, this is certainly a spot where we could see this happening as an infinite loop. When we did this, we said brick count, brick number, so we're putting brick number to output, while count, we said count was going to equal 4, put count to output. So we've got 4, we put a space, and then that's it. We've gone right back up to our while statement, and guess what? 4 is still greater than 0, 4 to output, space, 4 is still greater than 0. We didn't do anything to change our counter. We don't have the line that we expected to see here that says count equals count minus 1. We have to have that. If we don't have something to make our conditional expression change to make it evaluate from true to false, then we're going to end up with that infinite loop. So we either need to have a counter, or we could have something of called a sentinel value. A sentinel value could be where we're telling you to enter all the numbers that you want, and then enter minus 999 when you're finished. So maybe you'll just do 4, 3, and 9, and then put your sentinel value. Or maybe you'll do 4, 9, 8, 16, 72, 44, however many you want. It's going to keep going until you put that sentinel value in there. Very good, everybody. Let's do one more loop question. In the following line of code, which is the loop condition? Loops are so important. When you are writing a program, loops simplify your life. They allow for automation, get rid of so many of the repetitive tasks that you have. So you need to know loops, absolutely. Take a look at a slide here, a couple of slides for you. Oh, look there, I had more on that one. Here's a loop basics. I want to just point this out to you. So a loop is a program that repeatedly executes a list of substatements. That's called your loop body. So everything inside that's being evaluated or happening, that's called your loop body. The loop expression, when that evaluates to false, the execution proceeds past the loop. So it's going to keep executing until the loop expression goes from true to false. And each time it does that, that's called an iteration. So some vocabulary. Vocabulary are nice, easy questions to get for an exam. There were 3 types of loops that we just covered. First was it wasn't really in this order, but the while loop. That's going to repeatedly execute while the loop's expression evaluates to true. So a while loop may not necessarily evaluate, or it may not execute at all. If we get to this spot and it says, while x is greater than 4, do such and such, and it says, hey, x isn't greater than 4 at all, then it just skips right out of that loop. It's not going to do anything. Your do while always executes the loop body statement at least once. Then it's going to evaluate to determine if it needs to run again based on the conditional statement. The for loop, that's be the one that you're probably most familiar with. That's when we know how many times we are going to iterate. Yeah, these are important. So let's just take a look at 2 different ones. Here's our for loop. Our for loop is nice and convenient because everything about this is right up top. It has our 3 conditions that we just talked about, or that I showed. Here is your loop initialization, I equals 0. But guess what? Our while loop is going to have the same thing. Look, here's our while loop. Here's our initialization. Here's our conditional expression. While I is less than n, it's going to keep iterating. Look at here, conditional expression. Here's our counter, might be called an iterator. Here we have it, or else we're going to end up with our infinite loop. And then here's our loop body. Here's our loop body on that. So all the same components are going to be expected there. With a while loop, we might have a sentinel value. So that's something to keep in mind as well. Probably not as important. How we doing? How we doing? Halfway through our game. Got some great scores. Let's move to functions. A couple of questions about functions. Functions are hands down the most technically challenging portion of this class. Really, for programming in general, functions are going to be something that just make it more difficult to work with. So the question says, what entire output appears after 3 calls to a function named fun? I'm so creative with my naming. I know. And I showed you the actual function there on the screen. I have a number of people who just slightly chose wrong, slightly chose wrong. That's why, again, I want to point out, be very careful. Make sure you are answering literal. Computers aren't smart. They're only going to do exactly what we tell them to do, no more, no less. When we call this function, the only thing it does is it writes the word Legos to output, no spaces or anything afterwards. So Legos, Legos, Legos. See, we had a number of people that put the space in there. That's close. Probably a little too tricky. Hopefully you wouldn't see anything like that on your exam. What's the other? See, some people did the counter. No, there was nothing in there to be putting any kind of a number with that. I like what you were thinking. Another function call says, what value results from the following function call? Bricks 7. I think what makes functions so challenging is that there are a number of different variations, scenarios that you can run this. You can call a function with no value. You can send a value to your function. You can call it with a parameter. Inside the function, you can return a value, but you might not return anything at all. When we look at this, we don't really know what's going on. Well, actually, we do. I told you I'm calling the function with the command bricks7. So down here in your main part of the function of your program, you have a line that just says bricks7 that says, hey, come up here, call here, initialize our function bricks. It's accepting a value. So that's the 7 that we sent in. It's going to say, hey, we've got a value we're going to be working with. That's an integer. It's named X, and it happens to be the value of 7. And once we're done with this function, we are going to return a value called Y. Let's get into the program. Y is equal 3 times X, whatever was sent into it. That's 7. That's the end of our function. Didn't actually do anything to start with, but it is returning this value. Once it's done, it says when you're finished, return whatever the value of Y is. Y happens to now be 3 times 7. That's going to be 21. I don't generally promote doing the labs for this course. They can be extremely challenging, quite time consuming. However, if you have the time, check out one of the labs for each of the exercises. Functions, it can really help your knowledge if you do a little bit of coding and play around with it, really do some experimentation on the functions. All right, let's move back out of functions. Let's look at something else. This one says a variable should hold the color, such as red, of each brick type. Which data type should be used? So we've got a number of different brick types. We need to keep track of the colors for all of them. How can we do this? We do this with a string array. There are different types of arrays. We could have an integer array, we could have a float array, but string is for text. Like I said, we're keeping red, blue, green, so we're going to have that. Next says, what is the value of weights 2 in the following array? Here's the thing you need to keep in mind with arrays. Arrays, much like many things that we'll find in computers, begin counting at 0. When we look at this array, we have 1, 2, 3, 4, 5, 6 items in this array, but they start at 0. So when I'm referencing weights 2, I have to start off at 0, 1, and 2. So I'm looking at the value 9. Anytime we are looking at that, when we see an array and then an element number, if it says 2, that's actually the third in line. It's kind of weird the way that works, but we're not starting counting at 1, 2, 3. We're doing 0, 1, 2. So that's what we're definitely looking for. That's it for arrays. That's the only question. Let's go to algorithms. Algorithms are all about putting things in the proper order and doing things logically. For that, we're going to look at putting this in order. So if we're ordering the following algorithm properly with the first step on top, how are we going to best build our Legos? Logical order. And I teach the lesson on this. One of the things we talk about is that your feet are wet, and we look at an algorithm for that. Sometimes algorithms aren't all computer; they can be real life scenarios. It says, uh, take your socks off and dry your feet, and then take your shoes off. Well, does that make any sense? How are you going to take your socks off before you take your shoes off? You've got to have it in the right order. When we look at this, in order to build our Legos, the first thing we have to do is open all of our bags. Well, maybe you think that that's not necessary, but can you possibly sort the pieces while they're in the bags? Nah, it'd be hard to do. Can you assemble the pieces if the pieces are still in the bags? No, you can't do that. You have to put it in the right order. You have to open the bags. You need to sort them. Once they're sorted, you can then build them. After that, you can then test, play, and enjoy. For algorithms. By the way, remember, algorithms are only chapters 7.1 and 7.2. The rest of it are not necessary for this course. That's an entirely different course. So, order the 4 stages of the software development lifecycle. Top is the first layer, first stage. Lots of portions, lots of questions that you can expect on the software development lifecycle. And they follow the following stages: analysis, design, implementation, and testing. That's always the order. We've got a new leader with the highest answer streak of 10, too. Oh, you're not a leader, though. I think you'd already been the leader, but congratulations on that streak. The UML, this is something I definitely was not familiar with. I had done programming pretty much all my life, but never in a formal shop. So, the question says, what is the purpose of the UML? That is the Unified Modeling Language. Unified Modeling Language. There's a number of things that you're going to find to go along with this. We'll look at some slides. This comes, it's all about visualizing the structure and behavior of programs, and it's done with various charts. Here are examples, 4 charts that we cover in this course. Now, many courses you can go out and find outside resources to support your needs. I really discourage that for this course. If you go out and you look at other resources for this, you are going to find so many more so many more diagrams for the UML. You only need to know these 4 for now. This is the introduction for it. If you really go and explore Agile, you're going to see that Agile is a very large course all on its own. We're only teaching a small portion of it. So stick with your official learning resources for the course. Here are 4 diagrams that we cover, and I've included them as to where you're going to see them in the software development lifecycle. So in the analysis phase, remember, these are just very rudimentary designs. These are people who know they want to build a program, but they don't know how to build it. They don't know the specifics. They're going to draw this out with some crayons and stick figures. Just says, hey, this is kind of an idea of what we want the program to do. They take that and they send it to a designer. In the design phase, this is kind of your architect. They are going to create the documents, the official workflow as to what needs to be made in this program. Maybe such as this is our class diagram is going to define the class itself. Mention what sort of variables are included there, any sort of functions that are happening, things that are going to be returned. During implementation, this is the programmer. This is where the coding actually takes place. And the coder is going to make these activity diagrams to get an idea of how they're going to write out the programs. And then lastly, in the testing phase, they will create and use a sequence diagram to do the formal testing. Last thing I'll mention about this, even though in analysis, they create the use case, in design, they create the class. Design is going to look back at these previous created diagrams. Design is relying on this use case to do their work. Implementation is relying on this class diagram, relying on this use case diagram to do their work. Okay? All right, and our last half a dozen questions or so says, which UML diagram is created during the analysis phase of the software development lifecycle? Oh, it seems like I presented that to you one slide early. How embarrassing. Well, everybody should get this one. The analysis phase. Think use case. Yes, the use case. That's right. The use case, that's where there's people who say, we know we need a program. We know how to make it. Still very smart people, perhaps. Well, let's continue. This is still chapter 8. We learn about a couple different programming methodologies named Agile and Waterfall. So which methodology has clearly defined stages, each processed and completed one at a time? It's going to be Waterfall. Waterfall is all about uh, being very, very structured, very rigid. Remember, waterfall is also the idea that you're going over the waterfall, and once you go down, you can't go back up. So it's a one and done operation. True or false for you? Waterfall and spiral are two names for the same methodology. Kind of tricky that you see spiral show up. But it turns out waterfall is always just waterfall. Agile and spiral are the same things. It's two names for the same thing. Spiral's kind of nice if we think about that because where waterfall is one and done over, the agile slash spiral, it is iterative. It is going to repeat itself, probably like in 2-week sprint cycles or for various other reasons, you're going to repeat the process. That's how agile is designed. So spiral and agile are the same. You're asked to know about different types of programming languages. This one says, which type of programming language has tags surrounding text? Sorry, you're most familiar with this. If you've seen any sort of HTML code, the M in HTML stands for markup. So that is a markup language. 28. Now this gets to your final chapter. This is all about programming concepts. It says dynamically typed languages can convert an integer to a float. It's a true or false question. What do you think? Slide. So here is your dynamic languages. With your dynamic, you're looking at this. Your static languages cannot change a variable type. So, for instance, Java, C, C++. Uh, if you say x, your example is that you have an integer named x, and x equals 5. That's fine. But what happens when you do division? You say x equal x divided by 2. It is not going to it's not going to give you what you want. What should happen there? Well, you would expect x to become 2.5. Depending on your language and how this works, if you are working with a static language, a couple things can happen. A few different things can happen. One, kind of preferably, it's just going to blow up and say, hey, you can't do this. But alternatively, it may just round. So maybe instead of it becoming 2.5, it's going to become 3. Or another one is that it could just do floor division or truncation where it drops off the end. So all of a sudden now x would become 2. In either case, that's not what you're looking for. You generally need precision. Your dynamic languages, such as Python, change variable types as needed. So that can be a definite, definitely a saving point for you. Here's an example. If we see this x equals hello, well, to start with, this is just a string. We can say print x, we have hello. We're changing x to 5. Well, look at there now, it's an integer. X equals x times 1.5. No problem. It will let it change. It's dynamic. It's nice and flowing. Static, kind of like waterfall, it's very rigid. It's not going to work out for us. Few questions to go. Scripting languages and interpreted languages are the same thing. Sometimes we end up with multiple terms for the same thing, and sometimes there's good reason, sometimes not really. So for this one, it turns out scripting and interpreted are the same thing, right? Make sure you remember that. What's the other one that we're looking at? It's compiled languages. Compiled are completely separate. Compiled are compiled. Scripting and interpreted are the same thing. All right, last question. Had a good time with you. Can't wait to go look at all the chat bar comments. Which type of programming languages only executes on a specified platform, specific platform? So if you this program has been written for Windows, it's only going to work on Windows. If it's been written for Linux, only going to work on Linux. Yeah, compiled. Compiled's what we're looking for. So you want to make sure that you understand the differences between compiled and scripted. I encourage you to take a screenshot of this. Compiled is very specific. It will only work on that specific system, Windows. Maybe if you're working with Intel processor versus an ARM processor, it's going to only work for that. Why? Because it's already been compiled down into these zeros and ones, into machine language. Because of that, it's fast. It's already in the native language on the computer. But some downsides for this also is that you have to compile it for each run. That takes some time. It's kind of a pain. The program can only run together. Some examples include Java and C++. Scripted or interpreted means that this program can be run on any system with an interpreter, but it's slower than compiled. It can be run one line at a time. It can be modified at runtime. So examples are Python, Coral, and JavaScript. Compiled. You write the program, you compile it for Windows. It's only ever going to run on a Windows computer. If we think about our HTML programming language. Let's just go with that. When we write that, if you have an iPhone, you can view this as long as you've got a web browser. If you have an Android phone, you can view this as long as you open up your web browser. You go to your Windows computer, you can view it. Your Linux computer, your Xbox, anything. You go to your refrigerator. We don't know what that thing's running, but it's got that fancy screen. Anything that has that browser, that interpreter, is going to be able to run it. The disadvantage, though, it's a little bit slower. It has to translate it. So good things to know about compiled versus scripted. All right, let's see how we did. There we are. Thanks so much for joining us. And yeah, I hope you enjoyed the session.